Alright, let's look at the homework 2.5, problem number 9. Alright, so we have this piecewise defined function, and what we want to do is we want to find the value of A and the value of B so that f is continuous everywhere. Alright, so let's do that. Alright, so since each piece here is continuous by itself, so only problem that could occur is the gaps between pieces. So in this case, at x equals 2, there could be a gap. At x equals 3, there could be a gap. Right? So we'll make sure that f is continuous at 2 and at 3. Right? So let's look at the one-sided limit at 2 and 3. So we're going to look at the limit of f of x as x approaches 2 from the left, and the limit of f of x as x approaches 2 from the right, and the limit of f of x as x approaches 3 from the left, limit of f of x as x approaches 3 from the right. Right, so since x approaches 2 from the left, x is less than 2. So when x is less than 2, we need to use that top formula. So limit of, I'm going to factor x squared minus 4, so we're going to have x minus 2 times quantity x plus 2 over x minus 2, and x approaches 2 from the left. Right? So we can cancel out the common factor, x minus 2 on top, x minus 2 on the bottom. So we get basically 2 plus 2, so it's 4. Right? And when x approaches 2 from the right, then now we are looking at the parabola. So we have a limit as x approaches 2 from the right. We have ax squared minus bx plus 3. Right? So since this is just a quadratic function, we can just plug in. So a times 2 squared, so 4a, and negative 2b plus 3. Right? Since the limit has to exist at 2, so we have to make sure that the left-hand limit and the right-hand limit are equal to each other. So we set them equal to each other. Alright, so let's look at 3. So limit as x approaches 3 from the left would be, still, it's going to be a parabola, x squared minus bx plus 3. And if x approaches 3, so 3 squared, so 9a minus 3b plus 3. Alright? If x approaches 3 from the right, x is bigger than 3, so we have to use the last formula, the bottom formula, which is 4x minus a plus b. Alright? So 3 times 4, 12 minus a plus b. Then again, limit has to exist at 3, so left-hand limit and the right-hand limit have to agree with each other. Alright, so we have a couple of equations. We have 4a minus 2b plus 3 must be equal to 4. Alright, I'm going to actually just subtract 3 so that we get 4a minus 2b is equal to 1. Right? The second equation is 9a minus 3b plus 3. This is equal to 12 minus a plus b. Right? Then we can, let's see, I'm going to put the a and b on the left and all the constant on the right. So to do that, I have to move negative a and b over to the other side. So I'm going to add a and subtract b. Then I'm going to move 3 over to the other side, so I subtract 3, right? So a plus 9a is 10a, and negative 3b minus b is negative 4b. Alright, 3 minus 3 is 0, right? So negative a cancel out, the b cancel out, then we subtract 3, so that'll be 9, right? Then what I'm going to do is try to get rid of one of the variable, a or b. So what we can do is I'm going to actually multiply this guy by 2. And that way I can match the, negative 2 turn into negative 4. So 4a times 2 is 8a. And the negative 2, so it's negative 4b. And 1 times 2 is 2, right? Then we can just subtract. Right, 10a minus 8a would be 2a, and if 4b minus negative 4b minus negative 4b is 0. Right, 9 minus 2 is 7. Right, so therefore I can divide through by 2 to find a. So a is 7/2. Right, then we can use any equation here, but I like this one right here. So I'm going to plug this guy in here. Alright, so that we have, let's see, 4 times 7/2. So that will be 14 minus 2b equals 1. Alright. So we can subtract 14 from both sides. You get negative 2b is equal to negative 13. So we can divide through by negative 2 to find b. So b is 13 over 2. Right? So let's type it in. Right? A is 7 over 2 and b is 13 over 2. Alright, let's check. Submit for testing. Alright, it came back and looks like we got these guys correctly. Alright, that's it. I hope that this was clear.